Hey, so here's question 20, and it's a network one. So the first thing it's asking you is, well, draw a ring topology. Remember, always look at the marks. So what they're after is they're wanting it labelled. So you want to label all the nodes in the channels. So that's what you're after. Now they can be circles if you want, okay? But just make sure, have a wee key down the right hand side and the left hand side. So square's a node, line's a channel, and there's a ring network. Now, talking about handling data signals, okay, is one of the functions of the interface involved in data transfer. So what we've got is we've got a camera taking photographs, and then they're trying to just plug it into the computer. Okay, so obviously it has to be an interface. State two examples of status signals that the interface may have to handle when the data is transferred from the camera to the computer. Okay, so it's a number of things. Quite often, if you plug in these devices, it's a wee synchronizing signal, and you quite often find that if you plug in something like an iPod into your computer, it'll synchronize your iTunes with your iPod. It might also say it's maybe ready to receive data from the camera, or when you're transferring the data, it might say it's busy. So there's quite a number of them. Okay, so there's a camera, there's a laptop. So maybe just to say it's busy transferring the data, it's busy doing something else. They're synchronizing with each other. So the data on this is now the same as the data in here, or the fact that the computer's ready to receive. Right. Question C is the camera is connected via a serial interface. Why is serial transmission going to be described as more reliable? So remember that serial has two lines, one for the data and one to say for the control if it's maybe read or write. Parallel has 8 lines, okay? So 9, so 8 for the data and 1 for the control, okay? Now, obviously parallel you can send a byte at a time. With serial you can send a bit at a time. However, the downside with parallel, and this is why it's only used over short distances, is when these 8 bits that make the byte go down each individual wire essentially, they might not come out at the same end. So this is called skewing. So you'll end up having a big row of these ones and zeros, and it might end up getting to a stage in which the one in these bits that are all belonging to that byte get jumbled up with the next one. Okay, so that's when you can lead to basically errors in your data. So that doesn't have this, it's just one at a time. Okay, so that's like one water slide, one person comes out at a time. This is like 8 water slides in which you're trying to time everyone to end at the swimming pool at the exact same time. Doesn't always happen, so there is fewer transmission errors because that's the key word, there's no skewing. Okay, and what's happened is downloaded a file, and she uses both computers to access her online banking service. Both computers begin to show symptoms of a virus. So the computer's been watching and waiting essentially for her to be going online to the online banking service. So it just says here, name describe the virus code action that is demonstrated here. You don't need to include the VI, but it's watching. Okay, so it's just watching for a specific action, and that action is when she's going online to the online banking service. Okay, it might be watching for a specific date or for you to go into specific software. So this is watching for when she goes on to web browser, tries to access a bank account online. That's when the virus essentially kicks in. And the very last part is, what's the difference between a worm and a Trojan horse? Okay, so worm can self-replicate, okay, and your Trojan horse can't. Okay, so the worm can reproduce itself, self-replicate, but the Trojan horse can't do that. And that's question 20.